So chapter 5.3 goes over the intermediate value theorem. And this theorem states, let f be a polynomial function. The intermediate value theorem states that if f of a and f of b have opposite signs, then there exists at least one value, c, between a and b, for which f of c equals 0. And it seems a little intimidating at first, but if we draw it out, then it might make a little more sense. So let's say we have some function that looks like this. And then we're given some interval a to b. So if we locate over here, we have f of a right here. And then we have up here f of b. What this means is if f of a and f of b have different signs, so f of a is obviously negative here. So f of a is negative, and then f of b, since it's above the x-axis, is going to be positive. So since f of a and f of b have different signs, one being positive, one being negative, since f is a continuous function, this guarantees that there is some value c on the x-axis between a and b, such that f of c equals 0. In other words, it crosses the x-axis. Let's say our function looks like this, and we're given a over here and b over here. This time f of b is negative and f of a is positive. So since f of a and f of b are still different signs, opposite signs, there is still, it guarantees there's still some value c between our a and b that crosses the x-axis. So f of c is, again, 0. So we're given an example, f of x equals x cubed minus 4x between x equals negative 3 and x equals negative 1. And we want to use the intermediate value theorem to prove that at some point this function crosses the x-axis between negative 3 and negative 1. So we're given the interval negative 3 and negative 1. So a is going to be negative 3 and b is going to be negative 1. Then we can find f of a, and this gives us negative 27 plus 12, so negative 15. And then f of b is negative 1 cubed minus 4 is negative 1. So this is a negative 1 plus 4, and this gives us 3. So in this case, f of a is less than 0, and f of b is greater than 0. One is positive, one is negative. So this guarantees that there exists some c between a and b such that f of c equals 0.